Hello students! In our previous video, we learned about versatile nature of carbon and its allotropes. We know that these allotropic forms are possible because carbon has the unique property of catenation. Students, recall that catenation in simple words means self-linking of many atoms. That is, it is the ability of an element to form bonds with other atoms of that same element. So theoretically, catenation can be defined as the linking of atoms of an element to form long chains and rings. There are many elements that show catenation. They are silicon, sulfur, carbon, and boron. But amongst all these, carbon has the highest tendency to catenate. And this is due to its unique atomic structure. And can you tell me why is carbon able to form such unique bonds with itself and almost all other elements? To know this, let's first learn about the atomic structure of carbon. The symbol for carbon is C and it has an atomic number of 6. Which means it has 6 protons. And as we know, in any atom, number of protons is equal to number of electrons. And so it has 6 electrons. Its electronic configuration is 2-4. That is, there are 2 electrons in its first orbit, K, and 4 electrons in the second orbit, L. And what is this outermost orbit, L, called as? Correct. Valence orbit. And these 4 electrons here? Yes, they are called as valence electrons. As you know, for any element, these valence electrons take part in the bond formation during chemical reactions. Now students, already you know that any element can become stable if there are 8 electrons in its valence orbit. And what is this rule called? Correct. The octet rule, where octet means 8. So far, in our previous chapter videos, we have seen that atoms of metals have 1, 2 or 3 electrons in the valence orbit. So they tend to lose them to obtain the octet configuration, while atoms of non-metals have 5, 6 or 7 electrons in the valence orbit, and they tend to accept electrons to form an octet configuration. So if we look at both of these processes together, we find that metals donate electrons and non-metals accept these metallic electrons. Eventually, they form positive and negative ions. Metals called as cations and non-metals called anions. These ions, being oppositely charged, attract each other in a chemical solution and form ionic bonds. But students, the fact is that metallic elements with 1, 2 or 3 or non-metallic elements with 5, 6 or 7 electrons are easy to gain or lose and form ionic bonds. But what about elements having 4 electrons? Losing 4 electrons or gaining 4 electrons to complete an octet is not favorable energetically. Both require a lot of energy, which is usually not available during any chemical reaction. So then, can you think of how elements with 4 electrons complete their valence orbit? How do they form an octet? One way is to share electrons. Yes, you heard me right. I said elements like carbon, who have 4 valence electrons, share them instead of giving or taking them to achieve an octet. And thus, they form special type of bond called covalent bonds instead of ionic bonds. For example, look here. This is a carbon atom. It has 4 valence electrons. Now it requires 4 more to make 8, isn't it? Yes. Thus it shares its all 4 valence electrons with valence electrons of any other atom. and it forms covalent bond. I hope now you can understand its name. Co stands for sharing and valence stands for valence electrons. Thus, covalent bond is a bond formed between atoms by sharing of their valence electrons. Students, you should keep in mind that covalent bonds are formed by many other elements and not only carbon. But carbon is different since it can form bonds with most of all other elements and with itself also to form long chains or ring type compounds, and hence can form so many different types of molecules. Thus, carbon is very versatile in nature. Now the question is how this covalent bond is formed. Think, or else we will learn about it in our next video.